Okay, so I've started the recording. As I said, this is the Oasis Post D3PLOT introductory webinar. My name is Sundip Shah. I work at the Advanced Technology and Research Group in Arup, and I'm based in London. So today I'll just go through the basics of D3PLOT. So this is an introductory session. If you'd like to know more, we can certainly provide some information to you. I'll give you an email address at the end. And as I mentioned earlier, you can type your questions in the box and I will try to answer them at the end of the session. Okay, so let's begin. So D3Plot is part of the Oasis suite. Oasis is the OVE Arup Systems. It's our in-house software company. Within the suite we have Primer, which is a preprocessor. LS-DYNA is the solver, and we have D3Plot, THIS, and Reporter, which are post processors. So today I'll give you an introduction to the D3Plot. D3Plot is specifically designed to read in LS-DYNA files, and it's designed to do that quickly. So the native format that we use in Arup is the PTF file, but you may know this as a D3Plot file. So D3Plot can read in either of those files. Within this file, we have the standard results in a binary format. So that's the nodes, the solid elements, beam elements, shell elements, all the elements, and we also have stress information, stress and strain information. You have to request this from Dyna in the usual manner. As well as this, D3Plot can read in what's called a ZTF file. Now, this is a special file that's written by Primer. And what the ZTF file does is it passes information about the model to D3Plot that isn't normally available, that isn't available in the PTF files. So, for example, we have information on springs, on seat belts, information about joints and rigid walls, spot welds, and single point constraints. So that information isn't in the PTF files, but we can write that in the ZTF file. It extracts that data from your keyword, and D3Plot can read that in. So that's actually very useful in actually manipulating our data and understanding which results we want to plot. D3Plot can also read in the LS-DA files. These are the database files that are written by Dyna, and it's useful for reading in information about spot welds, springs, and seat belts. Now, in some of the older versions of Dyna, we had the ability to output an XTF file, and D3Plot can read those in as well. Okay, the interface of D3Plot is very simple to use. We start off with the open menu, and we can read in the PTF or D3Plot file. As well as that, we can also choose to read in a number of settings and properties files. Now, I'll come to some of these later, but for example, if we wanted to read in a settings file, we could just tick the box here, and the additional data in the ZTF file can also be read in. So you can select, you've got full control over which data you want to read in. As well as reading in a single model, if you have large gaps in your file family, you can choose to input this number here, so that if you want to skip files, we can incrementally read in the whole model. And we have control about which window the model opens in. We can open multiple models in D3Plot, and we can either open them all in the same graphics window, or we can open them in different graphics windows. So you have full control over that. So just a little bit more information about the additional files that you can read in. We have settings files, And that contains window settings, so background color, component data color, transparency, basically the way your graphics window is set up. We can also adjust the data components. So both the properties and settings files can be used to do that. We can read in ASCII group data. So in your keyword, if you arrange things in groups, we can read that in. And the additional data that I alluded to earlier in the ZTF file, which is written by Primer, we can read that in as well. As well as that, we can read in contact data. So if you've asked for a CTF file, this is information about contact surface stresses and locations. We can read that into D3plot as well. And if you did have XDF data, springs and lumped masses, we can read those in. LSDA data such as spot welds and SPCs, that can also be read in. So we can read in all of the results that we desire. This is the basic layout of D3plot. So I will do a demonstration at the end of this session, so we can just interactively go through some of the areas that we cover in today's webinar. So briefly, this is our D3plot window. This is the graphics window. This is the main window. Hopefully everyone can see my mouse. The interface in D3plot version 14 is very similar to previous versions. And if you're familiar with Primer, then the interface is almost identical. So it's very easy to pick up. In the bottom left-hand corner, we have the dialog area. This just basically runs through all of the commands that you've gone through. So we can minimize that if that's not of interest to us. Now, in the middle here, we have our viewing and drawing commands. So from this area, we can set up our view, we can rotate the model, we can pan, zoom in, and so on. And we can also plot stresses or any other results. So that's very useful. We can also save the views that we want. In the bottom right-hand corner, we have the animation controls. So we can animate our model, we can pause, we can skip to a certain state. That's all very useful, and that's these menus are always available. Now further up in blue, we have our tools menu, and anything we select in the tools menu comes down into the menu tab, and any of the tabs that we select comes down into the current menu panel. And sometimes we might have some submenus within this. So for example, we're in the data menu here, and we can choose various controls on the data. Up at the top, we have our standard top menus, and in the middle, we have quick pick controls. And these are very useful for interactively clicking on the model and extracting data and doing things like blanking and so on. We can have dynamic viewing in D3plot. So if you're used to Primer, it's the same buttons as Primer. If you're used to some other software, then the left and right mouse buttons may be slightly different to what you're used to, but you can adjust those in the shortcut menu, and you can have user preferences, so you can adjust which mouse buttons do what. Right, so if we focus on the viewing area, we can select standard views. So we can, it's very easy, and there are shortcut keys to all of these. So once you know the shortcut keys, things in D3plot become very much easier to manipulate, and also very quick as well. We can manipulate the model, we can rotate it, and we can toggle between rotate, translate, and slide zoom. So that's very useful. Those are the standard things. When we come to plotting our model, we can either plot a line mesh, a hidden line mesh, or a shaded view. And the shaded view can be with or without the mesh overlay. Okay, so that's an example of how we can just plot just the model itself without any results. We can zoom in and we can fit the contents to the screen. These are all standard things. For the animation menu, we can play, pause, and skip to any state. We can also scroll the slider to move to a state that we want. We can also type in the state number or the time that we want, and D3plot will take you to the nearest value. Animations can be delayed. So for example, if they're running too quickly or too slowly, we can change the frame rate of the animation. We also have full control over which states are shown. So this is just an example where we're going from one plot state to plot state 50 here, or we can change the time to this value and we'll get the same result. So there's lots of options there. If you're running on a laptop, you might have a smaller screen, in which case we want to maximize the graphics area. And if we select this button here, then that maximizes the graphics area and all the side menus are not visible anymore. Okay, so one of a very useful and quick feature on D3plot is the quick pick menu, which is located in the middle here. From this, we start from the left and we can choose a command. Then in the middle, we can choose which item that command is performed upon. And then at the end, if we wanted to key in a particular, let's say, element number or part number, we could do that. Alternatively, we can just click on the screen. If you left click, that will perform the command. And if you middle click, that will undo the last command that we did. So an example might be the default is to blank. So we can blank, and the default is to blank parts. So in this case, if we left click on the screen, it will blank the nearest part. So I'll give you a quick demonstration of that at the end of this session. Okay, we also have full control over the entities that are displayed. So if we go to the entity menu here, we can display any of these elements, any of the elements there. We can also choose to display things like joints, spot welds, or cross sections. Or conversely, we can choose to turn them off. Another way that is very convenient for displaying things and blanking things is to use the part tree. So if you're used to CAD software, this is very similar. We have a list of parts all organized. In this case, we've used the include format to organize our parts. So if we select this, everything will be under the relevant include file, and then we can choose to blank or unblank various parts there. Okay, we have various display options in D3plot. They're accessed via the display options. We can choose the method that internal faces are displayed in 3D elements. We can also choose to display beams as their correct cross-section, or to display them as stick elements. We can also choose to display discrete beams, often used for connections. We can choose to display them as blobs, as spheres, and we can change the size of that. So we have good control over the way that things are displayed on our screen. The overlay for our mesh in shaded view, we can either choose to have no overlay, so this is like a smooth mesh, meshless. We can have the feature edge, which basically shows the outline of each part as a black line, or we can have the full mesh. In this case, we have all edges. Yeah? So these are all the mesh elements. And we can change the overlay color as well. We have full control over lighting. So we can change the ambient light. We also have various preset lights so that we can illuminate our model from different angles. We can choose to have the shading type as flat, smooth, or dithered, depending on how we want to display, for presentation purposes. Okay, hopefully everyone can see these. I'm going to talk about plotting results. This is a very powerful feature of D3plot because it is very quick in the way that it reads in files and plots results. So the two, hopefully you can see the animations. On the top left corner, we have just a shaded plot, and you can see that some of the parts have been made transparent. We've also changed the colors of the body in white in this case. On the bottom right-hand corner, you can see a typical stress result. This might be a cross tube component, and we can see that actually we can have some items that are contoured, so we're showing the stress result, and other items that are shaded. We can also change the transparency of various items. So that's very useful. This is basically, we're only interested in this crush tube and we're not interested in these other components. So that that makes it very presentable, very easy to see what's going on. Okay, so let's talk about the data plotting menu. Within this menu, you have a lot of control over what's plotted and how it's plotted. So for example, we go to the Data tab and then the Scalar 1 tab. We can select a category of result and then the component. So for example, in this case, the category is stress and the component is X direct stress. We can then choose the number of contours we want in our plot, anything from 1 to 13. And what we end up with is if we choose the contour options menu, we get a sub-menu down here and a whole list of extra options that we can use. So for example, we can change the level of contours, we can change the color of the contours, we can actually have user-defined contour levels, or we can ask D3plot to automatically change the contour levels to the minimum and maximum and just linearly interpolate between those for the different levels. And we can choose to change the display of the numerical display. Okay, so I've actually just gone through this, so that's all stated there on that slide. Again, in the contour area, we can choose to change the through thickness integration point. We can show the minimum and maximum results on our graph, and we can turn data averaging on and off. Okay, and some of the more advanced options are that we can choose to display different data components on the same plot. So for example, for solid elements, we can choose to display the X direct stress. For beam elements, we can choose to display the axial stress. And for, let's say, something like the dummy or the airbag, we can choose to display the velocity. So we can choose to display all of these items on a single plot. Another very useful feature is the ability to do an envelope plot. And what that means is D3plot will go through every single PTF plot state that you have and select either the maximum or the minimum value for each of those elements, and then give you one plot at the end. So that's very useful. And some of the more advanced features are that we can choose to change the frame of reference for the stresses and strains. So we can choose to have either global, local, or different coordinate systems. Okay. Let's move on to plotting modes. We have several different options for D3plot to plot our data. So the one that people mostly use is CT, which is continuous tone. So as you can see, the contours are on a gradation, and they're all uniform. They're very flat, and they're in bands, very well-defined bands. Okay, SI is more of a shaded plot, so you can see that these two are plotting the same thing, but we have lighting control here as well, so that this face and this face are in the shadow, and we also have fuzzy bands. Yeah. ISO plot is like an isotherm or an isoplot, where we have each of the levels are on a surface. Yeah, so these are surfaces of constant value. And the other option is a node cloud. So this might be useful for something like fluid, or if you have particles, then a node cloud might be more appropriate. Okay, so again, we're just showing you the difference between the continuous tone, there's no lighting, and the solid SI plot, where we have lighting and fuzzier bands. Okay, I mentioned this earlier, but D3PLOT can accept up to 32 models simultaneously, and the only limit on that is basically the limit of your computer RAM. Yep. So we can open a new model, and we can either open it in the same window or a different window. So we can have our models, we can have our 32 models all in different windows, or all overlaid on top of each other on the same window. We can also just open one model and have several different windows with different views for the same model. Okay. Again, we have a maximum of 32 windows. The other thing we can do with our multiple windows is, if we have the same model or different models, we can choose to translate those. So we can shift them. So just in the background here, we have the same crush tube, two different models overlaid on top of each other. And just in the foreground, we have that same plot, but the second model, model 2 in green, has been translated vertically downwards, and that makes it easier to compare the two there. Okay, as I mentioned earlier, we can open the same model in multiple windows, and this is useful because we can plot, we can have the same view, and we can plot different things. So for example, here I've plotted the X stress, the Y stress, the Z stress, and the von Mises stress. So we can get a really good comparison of what's going on. And this can help us understand what the behavior of this particular element or this component. We can sync the dynamic rotation between all of the windows. And when we do this, if we rotate one of the windows, one of the models, then it will rotate all of them identically. And we can also sync all of the models together so that they have the same view. And we can do that regardless of whether it's the same model or whether you've opened different models. Okay, another useful feature is cut sections. We can draw cut sections either as a thin plane, a thick plane, or we can choose to have a negative or a positive shown. So in this case, I've shown the full plot on one side, and then I've omitted the other side completely so that we can see this. Within the cut sections, we can extract the forces. These forces are calculated by D3PLOT. Okay, so let's move on. Some of the other tools and useful functions that D3PLOT can do are measuring. So in this case, we're measuring between two nodes, but we can also measure angles, and we can also measure between parts. And when we've measured something, we can also extract, we can click on this export to XY plot, and we can extract the time history of that measurement. So that's very useful. D3plot is intrinsically linked to THIS, which is another Oasis program. And what we can do is we can just click on one button and it will take the result from D3plot to THIS. THIS is a software that we use to plot time history data. Okay, so I won't spend too long talking about that, but that is a useful feature. So examples of XY data that we can plot in D3plot are either data versus data or data versus time. So data versus time could be the displacement time history. Data versus data could be one Mises stress versus plastic strain, for example. So this gives you the stress strain curve. And we can check, this is a very useful check for us because we can make sure that the LS-DYNA result is matching what we've input into the keyword. So this is one of the standard checks that you might perform. Okay, some of the other tools that are useful are the deform tools. And under the deform menu, we can explode parts, and this artificially separates parts by applying an explosion vector. We can magnify, and what this does is it magnifies the displacements. So this is useful for where you have very small displacements and you want to see what's going on. We can fix a node. If, let's say, you have an impact analysis and your body is moving quite a long distance and it's going off the screen, what we can do is we can fix a node on that body. So everything that is displayed relative to that fixed node. We can do shift deform, which is similar to fixed node, but in this case, we are fixing a plane rather than a single node. As well as that, we can have a reference node or a reference state, or we can apply a transformation. So within the magnify menu, we have full control over the global X, Y, and Z magnifications, or we can hit some of these default buttons. So if we hit ×5, for example, that will set 5 times magnification in X, Y, and Z. Okay, so we can, once we've plotted our results, we might want to save them. So D3plot can save static images. I recommend using a 24-bit PNG for your results. We can also have 2 or 4 times screen magnification for your plots in case you're presenting them in a PowerPoint, for example, and that's going to be projected onto a big screen. We can also output movies in AVI, motion MPEG, or GIF format. GIF format is useful for, again, for PowerPoints. Some of the other methods are you can, instead of outputting as an image, you can output as a PostScript or PDF file. And this is something, again, that I talked about, which is the link between D3plot and THIS. We can overlay the two, and we can have this thing called timeline, which will basically follow the graph in THIS with the plot state in D3plot. So that's very useful. So we can identify, let's say, in this case, the point of minimum acceleration, and then we can go to that plot state in D3plot and then see what's going on at that moment in time. Okay, some of the advanced functionality. We can have user-defined data. We can plot contact stresses. We can write keyword data from the results. and this will include the stresses and the strains. So if you've run an analysis and you want to include the results as the input phase to the following analysis, we can write out that keyword data. We can plot multiple data on a single plot. We can use command files, also known as macros. So we can save a set of commands, which will, let's say, output some results. We can save that as a command file. We can take another model and run the same command file, and it will very quickly reproduce the same batch of results. Some of the more advanced features would be using JavaScripting, and we can do a lot with JavaScripting, either with user-defined data again, or as an alternative to outputting some results in a command file. And D3PLOT supports all of the latest LS-DYNA advances. For example, the CFD solver, SPH, ALE, and electromagnetism solvers. Okay, so let's just go through some of those. One of the advanced options is user-defined data. We have several different ways for the user to define their own data. What we mean by user-defined data is data that isn't output from LS-DYNA, but the user wants as a manipulation of what is already output. So in this case, for example, this is this is just an example. I don't know when you would use it, but in this case, we are the component that we want is the local Z displacement, and the user, this particular user, has defined this user-defined data component as 0.5 times dx, which is the global X displacement output by dyna in the PTF file, plus 0.866 times dz. Again, that's the global Z displacement. So that's what this person has decided they want to plot. So this is obviously a very simple example, but you can see how we can manipulate this and plot various different things. So one of the things that we could plot is something like a triaxiality factor. So we would just perhaps have a solid scalar on that, and then we would use the options for von Mises stress. Okay, we can also output the contact data. So we can plot the contact stresses. You do need to request that when you run your dyna model. And some of the other plots that we can do are velocity plots. So this is an arrows plot. So this is a vector plot. So we're getting the scalar value here and the direction with the arrow on the plot itself. And again, we have full control over the way that appears, so we can change the arrow length, the arrow width, and the arrow color. Okay, and we can plot multiple data. So in this case, this is just an example, but the solid parts have von Mises stress plotted on them. So in this case, it's a steering wheel. Some of the other elements, such as the airbag, they have the velocity plotted on them. Okay, so I know this is a slightly, this is just an example. It's probably a bit of a strange thing to plot, but it's just demonstrating that we can plot lots of things on the same plots, and you can have a lot of information that is very clearly presented. Okay, we can record the command files or macros, or we can write JavaScripts, which are useful for post-processing results. And a JavaScript is typically used to calculate user-defined data. Okay, hopefully you can see some of these animations. This is just to demonstrate, these are all taken directly from D3PLOT. This is just to demonstrate that D3PLOT has support for all of the dyna solvers. On the left, we've got SPH. This is a bird strike into a wing. And on the right, if I play this animation, this is some kind of fluid structure interaction. This is some kind of fluid sloshing in a container. So we can see that we've got some deformation in the container as well as the fluid sloshes across. Okay, that's it for the presentation. What I'll do now is I'll give a live demonstration of some of the features that I've talked about. So let's open up one of these models. So I hope everyone can see the model. This is one of the models from the presentation. So I've just opened it up already, and we can see we've got the full mesh shown. So I can just toggle through. I can either go to display options and toggle through the different modes, right? So we can see what each of these modes is, or I can press the shortcut key Y and that will do a similar thing. Okay. If I go to lighting, I can change the lighting to smooth. So why don't I toggle it to this? And if I go to make it a bit clearer, and if I change the lighting to smooth, hopefully everyone has been able to see the difference there. So what that does is, instead of having a faceted mesh, it's smoothed out those facets. So that's useful for presentation purposes. So I'll just show that again. I've gone back to the flat and I'll go back to the smooth. So that's the difference there. In the quick pick menu, I can change this to blank and I can change it to parts. So I can just left click. I'm just left clicking these parts, or I can drag a box and it will blank all of that. If I've made a mistake, I can just middle click and it will undo the previous blanking function that I did. I can change this to only, for example, and change it to an include file. So, and then let's click on the dummy. So now I'm very quickly only showing the include file for the dummy. So that's very useful. If I middle click, it will just undo the last option. Okay, so let's go back to blank and parts. And perhaps let's go to transparency. I'm going to make the roof opaque and I'll just change the color to blue, for example. What I'll do now is I will animate the model. I think it's probably likely to go across the screen. If you can't see the animation very well or it's stuttery, I apologize for that. So the animation has played through. I'll just scroll to the end. I can see it's gone off the screen. So what I'll do is I'll just do deform and I'll fix a node and I'll fix the node just at the front there. And I can show that node. Right, so we're showing this node is fixed. And if I play the animation again, hopefully it won't go off the screen. It'll be easier for us to see. So, okay, there we go. All of the displacements that we see are relative to this fixed node. Yeah. Okay, so I know a lot of this model is actually rigid. So, but if I let me try and plot some stress results. So, as well as the quick pick menu, I can also right click on something. So I'm just showing the steering wheel. Okay, and let me plot the von Mises stress. So I go to category stress and then component von Mises stress. I'll turn averaging off. Okay, and then I'll press CT. Okay, so that's what we have. And I can just press this AC button and that will fit the whatever's on the screen, that will zoom in and fit it to the screen. Now I'm just dynamically rotating this model. What I can do is I can just turn off that fixed node. I don't need to show that node. Press that again. I'll toggle the mesh so you can see what's happening there. If I turn averaging on again, we can see that we get the averaging between the adjacent elements. If I show the same plots in SI, we can see a slightly different shaded view with some shadows. So I think it's up to your personal preference whether you prefer continuous tone or this solid inference. I personally prefer the continuous tone. So that's what we have there. What I wanted to do also was to show you, so I'll just unblank everything. I can just click on all here and then AC. I wanted to show you just a measurement. So let's measure between the dummy and the steering wheel there. So I've just chosen just arbitrarily some points. I can export that to XY. You can see that it's very quick. Once you've read in the data, the response is very quick. You don't have to keep rereading in data. Once it's in the computer memory, you know, it's everything is very quick. And let me just plot the resultant displacement. So I'll just plot that. So this blue line here is the resultant displacement. So I can show that on a grid as well. What I want to do is I want to export that to THIS. So it will open up a session of THIS and I'll just export that. So I've done that. So that's good. So I'll just show you this. So I've got I'm showing something very simple, which is this measurement between the dummy's nose and some portion of the steering wheel. Now in THIS, what I can do is I can show you a timeline. And let me just go back to D3PLOT. Maybe this view is a little bit easier to see. Hopefully everyone can see that clearly. And I'll just go through step by step so that people can see the value there. You can see that the magnitude here corresponds to the value here. So that's all good. And then if I play it, the timeline plays through, right? Okay, and then let's say I wanted to go to this particular point. I was very concerned about some value here. So that's what's happening in D3PLOT at this moment in time on the THIS graph. So that's very useful. Okay, that's the end of the demonstration. If anyone has any questions, please do ask in the chat box down here. If anyone wants me to demonstrate something in particular, I can also try to do that. Okay, if there aren't any questions, then I'll just leave this final slide back on the screen. If you do have questions, please do email dyna.support, dyna.support@arup.com. Yes, thank you for your attention. That's the end of the webinar.